Okay, good afternoon, everyone. In the last class, we have started with dual nature of matter and radiation, right? So, in dual nature of matter and radiation, we have discussed some of the definitions, photoelectric effect, threshold frequency. Then we have discussed that is photoelectric effect experiment also. So, based on the experiment, we have some results. Based on the experiments, we have some results means the result is like the factors which affect your photoelectric effect. Okay, the factors which is affecting the photoelectric effect, already we have discussed the first one which we have discussed, that is intensity of light. So as you know, the intensity of light increases, the photoelectric current also increases. It is directly proportional, already we have discussed. So the next, today we are going to discuss. Actually, we have started this yesterday, but you people were not able to hear that. So once again, I'll repeat it. That is the effect of potential. So when we are discussing effect of potential on your photoelectric current, we have two concepts. When the photoelectric, whatever that setup you have seen, when it is positively potential, when you are giving positive potential to the circuit and when you are giving negative potential to the circuit. Okay, so when you are giving positive potential to the circuit, the current value goes on increases. The current value goes on increases when your circuit is given by positive potential. I hope you will understand what I mean by positive potential. So in the diagram, if you see, there we have connected a battery. So when it is anode is positively connected. So there in the vacuum chamber you have anode and cathode. So anode and cathode, two electrodes were there. So when anode is positively charged, that time the current value goes on increases. After some value, the current remains constant. Constant मतलब क्या होता है इधर? आप पोटेंशियल दे रहे हो मगर करंट वैल्यू रिमेन्स सैचुरेटेड, मतलब वो ज्यादा भी नहीं होता कम भी नहीं होता, इट विल नॉट इंक्रीज और डिक्रीज. सो द करंट रिमेन्स कांस्टेंट हियर. That current is known as what? Saturated current. That current is known as what? Saturated current. Means even though you are increasing the potential, the current value remains constant when anode is positively connected or positively charged, you can say. Okay, so this is when anode is positively charged. What happens if anode is negatively charged? If you remember the circuit, so here when anode is negatively charged, that time whatever your current is there, it will goes on decreases. It will go on decreases, and here the value becomes zero. The value becomes zero. So why current value becomes zero here? Because when anode is negatively given by negative potential, when anode is negative potential, that time here whatever the electrons are coming out, they are not having capacity to reach your cathode plate. They are not having capacity to reach cathode plate. Because of that reason, when electrons are not there, obviously the current flow will decrease. Therefore, the current flow decreases, the current electric current in the graph also decreases. Then it becomes zero. पॉजिटिव पोटेंशियल में क्या हो रहा था? पॉजिटिव पोटेंशियल में रिमेन्स कांस्टेंट, द करंट रिमेन्स कांस्टेंट, एंड इन नेगेटिव पोटेंशियल द करंट इज बिकमिंग zero. So here what they will say, the particular value of potential for which the current becomes zero or decreases, such a potential is known as stopping potential. Such a potential is known as stopping potential, or it is also called as cut off potential. Are you getting? So it is also called as what? Cut off potential here. Is it clear, everyone? So let us see the nature of the graph, what you are getting here. Okay, so the nature of graph, you have something like this. So our graph is along y-axis, along x-axis. So along y-axis, I will take the potential V. Along okay, potential only we are varying, no? So potential V, and here along y-axis we have, that is photoelectric current. This is not only current, it is photoelectric current. Here we are taking negative axis also. This is your 0. We are considering negative axis also. So the nature of the graph is something like this. So here the nature of the graph will get this. So this is when anode is positively give a positive potential and the negative graph is that is anode is negative potential. Okay, so here you can represent I1, I2, I3. So if you see the textbook, it is something somewhat straight line. What is the meaning of that here? The current is remaining constant. The current is remaining constant after some value of potential. After some value of potential here, you can see after some point the current is becoming constant, saturated. Saturated means what? For example, after 1 p.m. you people will have lunch. So after immediately after lunch you will be full. So immediately after lunch, if someone comes and gives you chocolate or ice cream or any dessert, anything, will you able to have it? No. If you are full, then you are not going to have it. So that is what you are in a saturated manner. You are at a saturated state. You don't want to take it. So here in the same way, the current becomes saturated after some point of potential here. So such a current is known as what? That is saturated current. Such a current is known as saturated current. Next, what you are doing? You are making anode negative potential. That time the current value goes on decreases and it becomes zero. So the potential for which the current becomes zero is known as cut off potential. Cut off potential or stopping potential. Cut off or stopping potential. Is it clear? So this is what this is the effect of potential on your photoelectric effect, right? So this is regarding the second factors which is affecting your photoelectric current, that is photoelectric effect itself, right? So here they may ask you why it becomes zero. Why it becomes zero? Because during negative potential of the anode, during negative potential of the anode, the electrons don't have the capacity to reach the cathode plate. मतलब उसका kinetic energy decrease होता है when you are giving it to the negative potential. So when the kinetic energy reduces, the electrons are not having energy to move from anode plate to cathode plate. इसलिए क्या होता है? When it will not reach, that time you will not get any photoelectric current. Or okay, so sometimes if it reaches also, it is not having that strength to give the photoelectric current. There are two reasons you can see. Okay, so this is regarding what? Effect of potential on the photoelectric current, right? Okay, so the next point we will see, that is the frequency. So next point we are going to discuss frequency, how it is going to affect. So the third factor is first factor is intensity of light, second factor is potential, third factor is frequency. As you know that the photoelectric effect takes place at certain frequency. So the frequency is known as what? Threshold frequency बोलते हैं हम उसको, correct है? The minimum frequency for which the photoelectric effect takes place, that is known as what? That is called as threshold frequency. So when you are doing the experiment, means when you are doing this photoelectric effect experiment, when you are verifying it for different frequencies, frequencies, you are keeping intensity of light constant. Do you remember in the first point, that is when we were discussing regarding the intensity of light, we kept frequency constant. Okay, मतलब एक factors जो आप study कर रहे हो, during that point you are keeping some other point constant. First factor intensity of light पढ़ते वक्त क्या constant रखे थे आप लोग? Potential constant, sorry, frequency constant था हमारा. Okay, then next when you are discussing about the potential, that time both frequency and frequency and intensity kept constant. Only we were varying the potential. Then the third point, when you are studying the frequency, we are keeping same intensity. We are keeping the same intensity of light. मतलब intensity of light fix रखते हैं, frequency vary कर रहे हैं हम लोग. Understanding? So when you are studying different factors, we need to keep the other quantities constant. Then only you can do proper study on the particular factor. Understanding? Okay. So here we will see what is the nature of the graph, how it is going to affect, how frequency is going to affect. So the nature of graph is something like this. So here you have frequency. So frequency is okay, new symbol it is frequency. Then here you have stopping potential. Here it is stopping potential. I have written here mu, that is frequency. Here it is stopping potential. So if you plot the graph something like this, you will get the nature of graph. So this you can say mu naught mu1 मतलब frequency, दो frequency हमने लिया है इधर. Okay, so if you study the nature of graph here, if you study the nature of graph, the value of stopping potential is different for different frequencies. See, what is this graph indicates? The graph between the frequency and the stopping potential at constant intensity. What is that? The value of or the graph of stopping potential versus frequency at constant intensity of light is constant, or it remains parallel, or it remains straight line. What is the meaning of this here? Here it is a straight line. It means that here for certain frequency stopping potential is zero. Here you can see that there are some frequencies for which the stopping potential is zero. So that is the meaning of the nature of the graph here. What they will say, the frequency for which your stopping potential is zero. The frequency for which the stopping potential is zero. The limiting frequency is known as what? Threshold frequency. The limiting frequency is known as what? Threshold frequency. So what is threshold frequency? Here it is the minimum frequency of incident radiation which is sufficient to eject electrons from the surface of the metal. That is denoted by mu naught here. That is denoted by mu naught. So here they will just say that if you plot the graph between paragraph कैसे शुरू करोगे आप लोग? That is the nature of graph for the frequency versus stopping potential is as shown in the figure. The graph is a straight line, which means that for certain value of frequency the stopping potential is zero. That minimum frequency only we call it as what? Threshold frequency. The threshold frequency is in which the potential is zero, or it is the frequency at which the electrons will leave the metal surface, and the corresponding wavelength is known as what? Threshold wavelength. Are you getting my point? Threshold frequency and threshold wavelength. Threshold frequency for which the current, whatever the electrons are there, it will leave the surface. It will just leave the surface of the metal. That meaning of frequency is threshold frequency. And the corresponding wavelength is known as what? Threshold wavelength. And the corresponding wavelength is known as threshold wavelength. I hope all these points are clear to you. Any doubt, students, due to intensity of light, due to the potential, and due to the frequency? Do you have any doubt? Here the thing is, you just need to draw the graph. First क्या लिखो? पहले ये point लिखो. Regarding which point you are explaining. Point लिखने के बाद क्या करना है आप लोगों को? Graph draw करना है. Then explain the graph. That's it. What you are keeping constant? How it is varying with respect to the other quantity. That's it. Is it clear? Is it clear, everyone? So three factors are over now. Then next, let us see, that is the fourth factor. Fourth factor is in the sense how this process takes place. That we say that it is an instantaneous process. Photoelectric effect is an instantaneous process. Instantaneous process मतलब क्या? Instant Maggie. What is that instant Maggie? Means here within a fraction of time or a fraction of second, the phenomena or the things can happen. That is called as instant or instantaneous in physics. So instantaneous process we say. Photoelectric effect is an instantaneous process. So what is the meaning of instantaneous process? Means as soon as the light, as soon as the light falls on the metal surface, the electrons will come out. That is nothing but what? Instantaneous process. So here actually we have some value also. Something it is of the interval of, I don't remember this exactly, it is something like 10 raised to minus 9 second. Means it will take only this much of time to leave the metal surface, which electrons will take this much of time to leave the metal surface. That is nothing but what? That we can justify that, or we can conclude that photoelectric effect is an instantaneous process. It is an instantaneous process. Is it clear? If it is clear, then we can conclude ourselves as law of photoelectric effect. So what is the law of photoelectric effect? The first one is law of photoelectric effect in the sense, what are the minimum or the basic need for this phenomena? The first one is, can you tell me what is the first one is required for this? Can anybody tell me what is the first point which we require here? What is the main basic point? From all the four previous points only you can conclude your law. Don't know, from 2 days you are learning this. See, the first factor is threshold frequency. The first factor is threshold frequency. Means the minimum frequency must be required to occur this phenomena. That is, photoelectric effect is possible only when it is having some minimum frequency. Means whatever light is incidenting on that, it should have some minimum frequency so that this phenomena takes place. Then the second factor is the photoelectric current is directly proportional to the intensity of light. It is directly proportional to the intensity of light. Are you getting? Then the third point is interesting one. Why? Because what they say about threshold frequency. So threshold frequency for time being I'll denote it by mu naught. Mu naught is what? It is a threshold frequency. Okay, students. So above mu naught, the photoelectric current does not depend on intensity of light. It does not depend on intensity of light, but it depends on frequency of the light. But it depends on the frequency of light. I hope you are able to see all the points. Okay. Then the fourth point is, it is an instantaneous process. It is an instantaneous process. So in exam, how they will ask you question? Law of photoelectric effect. Write a note on law of photoelectric effect. So what you are going to write? The law is something like, first one, the minimum means इसका definition लिखना है आप लोगों को. Here I have just written the key term. You need to explain it properly. It should require some minimum frequency. That is called as photoelectric effect. The photoelectric current is directly proportional to intensity of light. Third point, above threshold frequency, the photoelectric current does not depend on the intensity of light, but it depends on the frequency of light. Next, last point is It is an instantaneous process. It occurs in the time interval of 10 raised to minus 9 seconds. It occurs in the interval of 10 raised to minus 9 seconds. So this is regarding the law of photoelectric effect. This is regarding law of photoelectric effect. Do you have any doubt till now? This chapter is easy and little bit convincing also. Understanding? Aishwarya, Lakshmi, Rudraya, Zainabi, Sana, Uzma. All are getting no? Simple chapter it is actually. Okay. So I'll give you test. Okay. Let us start with the next concept, that is photoelectric effect based on Einstein's theory. So we have next Einstein's explanation for photoelectric effect. Already you know what you mean by photoelectric effect. Let us see what Einstein will say. So here till now what we have discussed, based on the radiations. Means क्या होता है? The light radiations are falling on the metal surface, the electrons are coming out, and it is giving the photoelectric effect. What Einstein will say here, whatever the electrons or the light radiations are falling on the metal surface, so these light radiations have discrete packet of energy. According to Einstein, the light radiations have discrete packet of energy, and that discrete packet of energy is called as, do you know what it is called as in chemistry? You might have studied, no? What it is called as, students? What it is called as? We have discrete packet of energies. So what Einstein will say, that is the light radiations which is falling on the metal surface, they are in the form of discrete packet of energy, and this discrete packet of energy is known as photons. Have you heard of this term anywhere? I think in chemistry you might have studied in first year. Okay. So what Einstein will say, light is in the form of discrete packet of energy which is called as photon, and these photons have energy is equal to, it is h into nu. Einstein will say that whatever light radiations are falling on the metal surface, they have the energy of this, that is h into nu, where h is the Planck's constant, nu is what? Nu is here frequency. Nu is called as frequency. Okay. So I hope you know the value, the constant of this h, Planck's constant value. Do you know what is the value of Planck's constant? Six point six four five. 6.64. Okay, into 10 to the power. 10 to the power minus 31, minus 27, minus 33, 34. It is 6.626 into 10 raised to minus 34 joules, right? That is what the H value, that is Planck's constant value. So here, what Einstein will say, he will say the light radiations are in the form of small discrete packet called as photons. They have energy is equal to h into nu. So what Einstein will say here, whatever this energy is there, this energy is used in two ways. So whatever your photons are there, these photons will come and collide with your electrons. These photons will come and collide with your electrons and the photoelectric phenomena takes place. So whatever these photons are there, they are having some energies. So that energy is getting distributed in the two forms here. One is utilized as work function and the other one is used as the kinetic energy. Are you getting my point? That is, here the collision takes place between that electron and the photons. That light radiations जो भी है उसको ही हम photon बोल रहे हैं, करेक्ट? So जो photon है वो जब आके electrons पे incident होता है within that surface, photoelectric phenomena takes place. It is an elastic collision. Always you remember that it is an elastic collision. In your first year you have studied elastic collision and inelastic collision. What we are saying, the collision between the photons and the electrons is an elastic collision. Here the energy is used in the two forms. One is as a work function and as a kinetic energy. मतलब आपका जो ये this h nu energy है वो split होता है. One is used as work function, मतलब one part of energy is helping the electron to come out of that barrier, one part of the energy, and the other part of the energy is utilized for the kinetic energy. अभी आपका जो सरफेस है, दिस इज योर मेटल सरफेस, आपका फोटोन आके इंसिडेंट होता है, नाउ it is electrons require some extra energies to come out of that surface barrier. First class I taught this one. So that extra energy you are getting it from the photon. Now what happens after getting that extra energy, the electron will come out. When that electron is coming out, that time it should require some energy to travel, that is kinetic energy, right? So here it is required some energy to travel from anode to cathode. So that energy is also given by this h. Are you getting my point? So here according to Einstein, the whatever your photon energy is there, it is utilized in the form of two. One is used as a work function, that is the minimum energy to require to escape the electron from the metal surface. Other is used in the form of kinetic energy, मतलब वो जो इलेक्ट्रॉन है उसको जाने के लिए कितना एनर्जी चाहिए, that is also given by this h. So here we can write Einstein's relation based on this concept. So how you are going to write? That is, see, your h nu is equal to, your h nu is used in the work function. You will denote work function as what? Pi naught plus. Other half is used for what? Kinetic energy, that is half mv square. So this is the most important relation which is given by who? Einstein. So what Einstein will say, your h nu is used in the form of work function as well as for kinetic energy. So this is the Einstein explanation for photoelectric effect. So again we have some different conditions for this, whatever maximum kinetic energy, minimum kinetic energy cases है हमें next. Okay, so I hope it is clear to everyone. So whatever doubts you have, you can ask now, or else we can continue with the next point in the next class. Any doubts, students?